Well, hello there, YouTube and makers, and welcome back to my channel. And if it's your first time here, welcome, as I make the Pennsylvania A-3 switcher steam locomotive engine in 3/4 inch scale to run on a 3.5 inch gauge track, as documented in Kozo Hiraoka's wonderful book. On this installment, I'll be working on the holding fixture for the tender wheels. I'll be making my fixture out of a piece of 1/2 inch thick, hot rolled round steel that was kindly given to me by the journeyman tool and die maker. For the initial thinning, I'll be taking cuts off of about 20 thou from the radius. As I get closer to my finished dimensions, I'm going to back that off to about 10,000 radius cuts, and then when I get to within probably 15 or 20 thousandths of my finished dimension, I'll split whatever's remaining. Probably take something like 10 thousandths and then a 5,000 cuts or something around those lines in order to get to my finished machine dimensions. Though, what I found is that the reality of it is I took off, when I was within 15 thousandths, I took off like 5 thousandths, and then my finished cut was about 3 thousandths, because at that point I noticed that the holding fixture, the tender wheel fixture I was making, was very warm, if not hot to the touch, and the chuck was quite warm as well, though the headstock on the lathe was quite cool to the touch. So just from reducing the dimensions and machining it, it had heated up the entire assemblage. So in the end, I was only able to do a final finish cut of about 3 thousandths to compensate and accommodate for the expansion of the hot rolled steel. Ideally, when I would have done this, in between taking measurements and cuts, I would have allowed my chuck and the fixture I was making to cool off for about 10 minutes or so and come back down to room temperature and reduce back down in size. Luckily though, in my instance, in this case, doing the 5 thousandths off the radius and then 3 thousandths off the radius at the very end, I had come into the dimensions I was going for. So it worked out this time. Though in the future, I might not be so lucky, so I'll definitely need to take time and allow my workpiece to cool down, especially when I get towards the end and making my final finished cuts. Now, in full honesty, you will see a bit of a discontinuity in the filming sequence as presented here. I had made a mistake in that I did not do things in an ideal order or router for machining this part. Some of that, in my excuses, is that I had obtained a really nice 5/16 by 24 NF die, and this one was made by a company called, or is made by a company called Desco Tools Co., and is actually a piece of tooling that was made in Japan. So for me, it had really been the first time I got to work with taps and dies that were not of lower grade foreign imports, and so I let myself get a little too excited because I jumped ahead of myself because I really wanted to try out this die. So there will be that discontinuity, though try to see past that, and what I'm presenting here is the router as it should have happened in order. So be sure to also stay to the very end, as we'll have our journeyman trick of the day. So to keep on top of it, and you never miss a journeyman trick or tip of the day, as well as any more sequences on my make, be sure to hit that subscribe button, as well as that, and hit that bell notification so that you're alerted and you never miss another video. Likewise, also please feel free to share my videos with anyone you think might be interested, and please comment below. I'd really enjoy interacting with y'all and hearing from you, as well as some of your guys' and gals tips and advice and anything that I can be able to kind of share with you, but also learn from you as well. All right, So with all of that out of the way, come on over here and join me at the bench, and let's make some chips. So let's start this thing off. I'm using a piece of hot rolled round, half-inch thick, or rather half-inch in diameter. I got this little piece of metal from the Journeyman Tool and Die Maker. Now, I should clarify that I'm being advised by two different journeyman machinists. One is a journeyman tool and die maker, and one is a journeyman machinist. So, this one very generously got from the journeyman tool and die maker. He's got this fantastic collection of drops and rims that he's had for years upon years, and he's happy to let me take some metal whenever I need it, and save me the burden of scrapping my own metals. He's got some that he's happy to share with me. I think he said that this piece probably was sitting in the back lot of the machine shop for 30 some odd years or so. So it's perfect for my needs. Now here I'm just knocking off the mill scale and the exterior surface. I did that end, so now I'm going to face off the other end. I realize now, retrospect, watching this, is that I did make a mistake. And I was told I was making a mistake also when we went over this with the both journeymen, and that I am needlessly flipping and turning around my workpiece. And it's bad practice in that it introduces errors and problems every single time. And especially now, since I'm using a self-centering 3-jaw chuck, it needlessly introduces variations in the workpiece. It wouldn't be as much of an issue if I was just using a adjustable chuck and I was dialing it in every time. So now I'm kind of positioning the Arbor a little bit. I need roughly about 7/8 or 15/16 or so sticking out. And that was just a rough calculation I made based on the thickness of the wheel, the thickness of my softer metal washer, whether that's going to end up being copper or brass, as well as the thickness of the nut. And want to leave as much as possible left on the portion that's going to be in the chuck, because since I'm using a self-centering chuck, one of the things I'm going to have to end up doing is every time I load it and unload it, unless I use a dial indicator or something like a steric glass word indicator and I dial it in, I'm going to have to basically take a light passing cut to get it running concentric again. This point, I'm not quite there yet at 0.3125. So I am at 0.370 at this point. A little bit further to go along. I want to say about 58 thou or so. Now, I am, if you'll observe at the very end, purposely leaving that old patinaed mill scale. Since it's not going to be an indicating surface, I like having a little reminder of where I came from. At this point, I've got 58 thousandths left to go. It needs to be said that some machines or lathes, when they cut, their dials are set up to show you how much material is being removed and taken off by the diameter. In the case of the Sherline dials are set up for the radius. So I've got to remember that a radius is equal to two times the radius is equal to the diameter. So I want to go remove no more than 29 thousandths. In this case, what I've done is I've gone ahead and split it, and I'm going to remove, and the first part I remove 15 thousandths, and then 10 thousandths. The reason for this being is that
it's hard to communicate what's going on right here, but the workpiece is noticeably hot. And I don't mean warm, I mean hot. As well as the chuck is noticeably hot, though the headstock is quite cool to the touch. So I don't want to take the finished dimensions off because, as you can see, I'm already at dimension, and I need to compensate for the heated workpiece and and its coefficient of expansion. So in total, I went in to remove 25 thou off the radius, so 50 thousandths from the diameter, and it is a perfect fit. I mean, this wheel, it's just sucks itself straight onto there.
To get to the final dimensions that I need, or rather the machine dimensions I need for the threads on my holding fixture, there's a few sources I can look at to kind of figure that out. I can go to the tool menu, the manufacturer, or rather the die manufacturer's website, look it up and see what they recommend. I could just Google it and see whatever the interwebs say. Or best practice would be for me to use my copy, which is the 27th edition of Machinery's Handbook. This book knows all and has everything I need, and all the details that are kind of glossed over or briefly covered in Kozo's book. This has everything. Everything I need to make this build is contained pretty much within this. On my edition, on page 1738, has got the dimensions I need in order to machine the class 2A threads. So I go to page 1738, and he has a chart. And for my thread class, doing a class 2A says that I need an allowance of 0.0011, so 11 thousandths. And I have a major and minor diameter of 0.3114 and 0.3042. So you can see that's tremendously helpful. Some of you may be asking, what is a thread class? Well, if we go to page 1773 in the 27th edition of Machinery's Handbook, it explains all the different thread classes, internal, external. So briefly, since I'm doing a class 2A external thread, it basically says that those threads are the most commonly used for general applications, including production of bolts, screws, nuts, and similar fasteners. It has stuff on class 1A, 1 or 2A, 2B, 2AG, etc., etc. Now, the one I found the most interesting and that really jumped out of the page and caught my attention was the discussion on, let's see here, if I can find it real quickly, class 1A and 1B threads. Now, what jumped out was that it says these classes are intended for ordnance and other special uses. So I assume ordnances means like bombs and artillery shells. They're used to thread components where quick and easy assembly is necessary and where liberal allowance is required to permit ready assembly, even with slightly bruised or dirty threads. So that's pretty interesting and pretty cool. And just really jumps out as something very different that I would not have expected to come across. I would love to know the history of why that's in this book and what's that related to. I've done some minor research to try and find out, haven't come in with any answers, but if any of y'all know, please comment below. I'd love to hear your opinions, perspectives, and especially if you could cite a source. I really enjoy the opportunity to kind of learn about that and to read up on the topic.
All right, let's get this started. So I'm going to take some blue die gum and mark up the basically the entire shank because that's just easier. And I'm gonna run this guy up in RPM to get it to dry off the blue dicom a little bit faster because this slow mount's just not working out. Though in hindsight, it was a bit of a mistake because I ended up blue dicom on my safety glasses, on my shirt, face, and up the wall and onto the light fixture. So I'm going to take my sample wheel and load that on there. I've already gotten a set of dividers roughly widthed out to the thickness of a steel washer and the potential thickness of the brass stock that I flat sheet that I have that if I ended up making my own washers from, so that I have a guide in which about to the depth I want to go to with my threads. When that's done, I can then get set up to machine down the threaded area based on my dimensions off of Machinery's Handbook, again from my 27th edition. In this case, what I'm going to do is I'm going to bring in my cutter just enough so I'm not removing metal, but I'm barely removing a tiny bit of blue dicom. And then I'm going to zero out my dials. So again, I don't want to remove any metal, just close enough that the blue dicom's removed. And when that's done, I'm going to take off my 3000s, but I'm going to try to split my 3000s. Just going to run it across on 0. Then I'm going to bring in my 3000s because I only need to remove 6 thousandths from the diameter to bring it into that 0.306, a little bit towards the lower end, according to Machine's Handbook. And that last cut, all I did was run it through without moving the dials, just to take a pressure cut. And that pressure cut was just enough to bring it right in at 0.306. Doing a class 2A external thread, I could take it all the way down to 0.3042, but 0.306 is towards the bottom end, but not all the way. So it should provide me plenty of clearance. I don't have to think about the threads of the arbor scraping against the interior of the axle wheel hole. I wasn't super duper happy with this setup here, but it worked. And extending out that cutting tool so far caused a little bit of chatter, and I was able to undercut the shoulder, though not leaving as nice a finish I would have liked. But fortunately, that finish doesn't interfere with the placement of the wheel against the shoulder.
So that's how I would have preferred to set up my cutter. So basically rotate it around my tool holder and then inserted a left-hand cutter and would have been able to hold it nice up and close, nice and rigidly, and brought it right up and close in order to put that undercut into the shoulder. With a good router, I would have only had that to do that one tool change. Luckily though, wasn't caused too much harm or trouble by that. Only a little bit of inconvenience of setting up my tooling. And what saved me was our journeyman trick of the day today. Now, if you had been watching any amount or any number of YouTube videos related to machining, you've probably seen this trick. So for me personally, I just didn't trust what I had seen on YouTube until the journeyman tool and die maker kind of shared with me his experience of how he had utilized today's journeyman's trick of the day in the machine shop environment. And today's journeyman's trick of the day has to do with setting up your lathe tooling, and this also applies to something like a drill press or a mill with a steel scale or rule. Now, what he explained to me is that this every journeyman more or less has in their pocket here. And the most important thing you use is for every morning is to stir your cup of coffee after you get your donut. And the second thing is to set up your lathe tooling. In the professional environment, he explained to me it was used where, yes, by the book, by your apprenticeship program, you're supposed to remove your chuck, insert a center, and then line everything up to the point of the center. Or use something like a height gauge and set up your cutting tool. It takes a lot of time, and the machine is down for quite a bit every time you do that operation. And in the real world machine shop, there may be a limited number of lifts that can be used. And a large lathe, the chuck could weigh 300-400 or more pounds. So you have to use a lift in order to remove it. Well, in the machine shop environment, you may be using that lift, but that lift is out of commission the whole time it's holding your chuck while you're putting in centers and you're lining up your tooling. And you've got a whole line of other machinists and journeymen scowling at you and mad at you because they can't begin their workday. They can't start to get paid because they need to use that parts lift so that they can just load parts into their machines and start their workday and start machining for the day. And the whole time you're doing that, he says, you've got a mean, bitter old foreman giving you the stink eye and scowling at you because you're setting up a machine instead of making parts. My handy dandy complicated model here represents a part being turned down in my lathe. And this cross here represents the center lines, both vertical and horizontal, and this being my scale or rule. I have my cutter here. So with my scale rule against the workpiece, my cutter here on the center line, if it were to be adjusted above the center line, and I were to bring my cutter into and against the scale and rule, you could see that it causes the top of my scale or rule to kick in towards the piece that's being machined. If my cutter were to be on center line and then brought in and pressed against the scale rule, you could see that my scale rule is perpendicular to the horizontal center line of the piece being machined. And likewise, with my cutter brought down below the center line and then pinching the scale rule, the top part of my scale rule kicks away from the part being machined, and the bottom portion of my scalar rule kicks in towards the part being machined by me. Earlier, I mentioned that I can use today's journeyman's trick of the day and apply it towards rounded objects that are in the vise of a mill or drill press and drill them. Utilizing also my steel scale or rule with the part on the center line. If I were to bring this representing my drill bit or cutter or pointed object down onto the center line of the object to be machined, you can see that my scalar rule is perpendicular to the vertical center line or parallel to the horizontal center line. Furthermore, if my object is defined the center and I were to bring in my cutter to the far area away from me, you could see that my scalar rule also tips. And it tips down, in this instance, in the direction of where the cutter is in relation to this vertical center line. If I were to bring my cutter all the way over to the closest area towards me of the center line and bring it down, you can see again my scalar rule tips down in the direction that my cutter is in relation to the vertical center line. And that, folks, is our journeyman trick of the day. So please be sure to hit that subscribe button as well as the bell notification so you never miss another video and you never miss another great, fantastic journeyman tips and tricks of the day.
So I'm going to start my die on there, and I'm going to use the tailstock of my lathe to apply perpendicular even pressure to get the die started, and I'm going to kind of rotate around. But again, remember, there's a bit of discontinuity in my filming, so I'm actually trying to thread at 0.312 instead of the 0.306. But I just couldn't wait to try out this die. So the handle is actually not touching the lathe bed. It's actually touching the aluminum plate my lathe is attached to. But it's starting to thread well, but then it gets to the point where the jaws of the Sherline are just not beefing up to hold it, and the Arbor starts to slide. So I'm going to move it over to my vise with it reduced to 0.306. Just to start threading it. I'm going to generously use a lot of tap magic because well-made, nice Japanese dies are expensive, much more expensive than a bottle of tap magic. Now here I've got it clamped and holding it with a piece of oiled leather, homemade oiled leather. So if you want to learn how to make your own, just keep a bunch of leather scraps lying around and a bottle of oil they call it. So what I'm doing is I'm bringing it down and threading it. Then, as soon as I feel it binding and twisting, I'm going to back up. And if you've listened carefully, you should rewind and go back and listen again. You hear a snapping or popping sound. So it's binding, and then I bring it back and you hear that popping, snapping sound. That's the chip break. So I'm twisting it binds, and then I back it off and you hear a snapping sound. And that's the sound of the chip breaking. And generally, as soon as I hear that chip breaking, I can start going back down. But when I check where I'm at, often see if I make it to the scribe line, and I go down, almost there. I don't even have a full thread, just a little bit. And there, go back, clean it up, pull the sucker off. Let's see how we do. Pretty good. I like that. I like that a lot. Clean that up. That's not going to be chips in the piece. Drop my sample wheel in. Nice. Solid bump. I think that's going to hold well. And I think it's going to do real nice when I start machining that flange. I'm looking forward to this, and I'm looking forward to sharing that portion with you.
This is it. I have got my wheel holding fixture. I'm really, really getting excited and happy. It turned out really nice. I'm really happy with the tightness and the lockup and the quality and finish that came out. I've really enjoyed machining, especially using this last little bit of hot rolled steel I got from the Journeyman Tool and Die Maker. It's been just a pleasure and joy to machine different things out of. And now that it's just about used up, I'm going to miss it. Now that I have my tender wheel holding fixture, I can begin machining the flange as well as the tread for the tender wheels. So be sure to hit that subscribe button as well as hit that bell notification so that you're alerted whenever new videos post and you never miss another segment on our make of the Kozo Hiraoka Pennsylvania A-3 switcher 040 layout steam locomotive engine in 3/4 inch scale to run on a 3.5 inch gauge track. And also be sure to share my videos with anyone you think may be interested so that we can continue to grow our community. Thank you for joining me today, and I look forward to our next installment where I'll be demonstrating how I machine the flange as well as the tread on the tender wheels of the steam locomotive engine. Have fun out there, be safe, and keep making chips.